Now let's look at the logic behind this two-point perspective drawing technique. As you can remember from our previous video, we first placed the upper view of the object with its one corner touching to the picture plane. In fact, we draw just this line and we named it as picture plane, and then we designated a point over this line, and we said that this represents the one of the corners of the this rectangle of the upper view, and by using a 30-degree angle and a 60-degree angle, we redraw the upper view of this prism, the purple surface. In fact, we can see it like this. Let's say that this is the edges of our A4 drawing paper, and if we look it in another point of view, we can see that this is our A4 paper, and our object is just standing right here. Because we are above the system and looking down, this is what we see actually, the edges of the A4 paper and our object positioned like this. And imagine that there is a semi-transparent screen touching this object along this edge here, and it is positioned like this. It is perpendicular to this flat surface of A4 paper, and because we are above the system, because we are looking down, we cannot understand that this is an actual plane, but we can just see this upper edge of this plane. So this line here, in fact, indicates this semi-transparent picture plane. This is why we call it a picture plane. And after that, we determined a point which we called a station point. And it is, in fact, the position of the man who is looking, who is standing in front of this object on this screen here and looking at the object at this point. This is where the man is standing, its station point. As you remember, we draw a ground line. In fact, that ground line is this surface, but this time we are not looking the system from above, but we are here and we are looking the system at this direction. So we cannot see the surface of the this red surface, and we can just see it as a line, which we call a ground line. And after that, we draw a horizon line. It was 50 centimeters higher than the ground line. And we can say that it is the height of this man. Imagine that he is standing on an object like this, 50 units higher than the surface of this white surface, the upper surface of this area, and his eyes are level with this line, which we call a horizon line. The vanishing points that we created are we can think them as the borders of the eyesight of this man. If we combine them with the horizon line, we can get our vanishing points. Let's look at the system a little bit closer. So let's say that this man can see between these 2 points, and these are the lines that we combine with the eyes of the man to the picture plane. So by transferring them to the down part of the drawing, we are in fact determining the left and the right vanishing points. Since this object this edge is touching to the picture plane, we can draw it in its true size. However, the other edges will be reflected or projected smaller than they are because the picture plane here, the projection plane, is between the center of the rays and the object itself. So this is what I am doing right now. I am combining the eyesight, the eyes of this man with this back edge, its two corners. When I do this, in fact, I am combining the lines, the rays, with the man's eye and the back edge of the prism. And I am trying to find this intersection, the lines that intersect with the picture plane here. That's this point here. And by transferring it to the projection plane, I am finding this line here, their intersection. And by combining these lines with the left vanishing point, in fact, I am determining the projection of this surface here. As you can see, this is how the man sees this object. If he is standing right here, he is seeing this orange edge as this one here. It is being projected on the picture plane. So we can keep going like this. I am now combining the upper and down corner of this back edge here. And by transferring its intersection, I am trying to get this line here. And by combining it with the upper part of this edge of the prism, I am trying to find how the surface is being projected over this picture plane. And here, for the last step, I can combine this back corner here, which is here, with station point. It means the eye of the man, so that I can find the intersection of this line with the picture plane to indicate how the man sees the purple surface due to this perspective projection. And this is the logic behind the two-point perspective drawing. Here, the upper part of the drawing is like we are seeing the system from above. This is how we see the system from above. This is the station point where the man stands. We are seeing this picture plane as a line here, and at the back of the picture plane, there is this object, but we can see just the purple surface, upper surface. And at this part, we are looking at the system from above, in front of the system, so that we are seeing the picture plane right in front of us. The horizon line indicates the eyesight level of the man, and the vanishing points can be thought as the borders of his eyesight. And by transferring these intersections down here, we will be able to get the perspective image or projection of the object. Yeah, this is how the man sees. All these intersections, if we combine them, we will get this image. And what is the logic behind all these distances and locations that we did in our previous exercise? Why did we do that? What happens if we change them? Let's say that as you can remember, we placed the upper view by using 30-degree and 60-degree angle, and we get an image like this. What happens if we have positioned the object like this? Let's say that this time I took 60-degree on this for this angle and 30-degree for that one. Let's do it one more time. But as you can see, I want to find the vanishing points. However, it is out of the borders of my paper. So I can just transfer this image so that the frame will get everything. And by combining the station point picture plane with parallel lines, I can designate the positions of left vanishing point and right vanishing point. So in fact, this is how the system looks like in its original state. We just rotated this object without changing the position of this corner here, so that the man is looking at it between these 2 points. It's the border of his eyesight. And I'm going to do the same again. Since this edge is connected to the picture plane, I am going to draw it in its true size. And then I will combine all the edges, all the corners with his eyesight, so that I will get the image of this object as it's being projected on the picture plane. And here you see, with this change of position, he is now seeing a larger portion of the orange surface and a smaller portion of the green surface. That's the main difference between two positions. And we can say that, yeah, this is the new one, and this was the first one we did. And let's say that what happens if I change the horizon line? As you can remember, in our 12th exercise, we took 50 millimeters for this horizon line, and we told that it's the level of the eyes of this man. Let's say that he is standing something over something like this. What happens if the horizon line was here? So we can get rid of the that thing, that base he was standing on, and he is now standing on the ground, and he is looking at the system at this level now. So I will do the same. I need to combine all the edges with his eyes in order to find the intersection points. And if I transfer these directions down to the projection plane, I am going to get an image like this. And now you can see that because of his the level of his eyesight, because of the level of his horizon line, he is no longer able to see the purple surface. Now he can just only see the green and the orange surface, like this. Just to compare the first type, the first position, and the second position, we can look down side by side. Here in the first exercise, the horizon line was here, and here in this type, we just changed the level of the horizon line, and the rest is the same, so that the difference is like this between two examples. And let's compare the first and the second one. As you can see, they have both the same level for the horizon line. However, the position of the object has been changed. The station point, they are nearly the same. And now we can compare the two images. As you remember, because of his position, he is seeing a larger portion of the green surface, in this version. And here on the right side, he is seeing a larger portion of the orange surface. And we can see them all side by side. Same position, different horizon line, same horizon line, different position. How the projection will differ. You can see that.